All right, so today we are going to be looking at more ways of, describing our data. And at the moment, the next thing we're going to be looking at is more numerical data. So these next bit of stats is we can do on the numerical part of the data. So the first things that we look at is we can look for the mean. Now in your calculator they'll use that symbol for the mean, the X with the line above it, and the mean is when you add all the data up and divide by how many. So for most of us in the real world, that's probably known as the average. Yeah, that's how we work out an average. Now another one thing that we look at is the median. And the median is the middle data. So what we often call these two are measures of centre. Okay, so they tell us generally where the centre of the data is. So for the median, it tells us the median is when we have the data organised from like lowest to highest. And the median is like in the middle, is the middle data. This is the median. So what will happen is you'll have 50% of the data will be below it and 50% of the data would be above it. So say if I gave an example of, say I took a group of kids and I asked them their ages. So say I had something like this. Okay, so here I actually have 5 pieces of data, don't I? So N is normally how much data you've got. So here I have 5 pieces of data. Now they are organised in lowest to highest. If I was trying to work this out manually, I'd have to make sure they are, and they are here. So if you have a look, this 16 is the median because can you see there's 2 below it and 2 above it. So it balances it, doesn't it? So it is like the middle value there. Okay, so and then what happens if I had an example of this is an odd number? So what happened if I had an even number? So say if I had 13, 12, ooh, no, actually, I'll do that. 15, 16, 18. All right, so if I was trying to manually do the median here, I'd have to make sure that that was actually in order. So because that 12 got shoved in there, I better put it at the front. Yeah, so now this is lowest to highest. Okay, now the median, there's an even number. So the median actually falls in between those two. So what's the number in between 13 and 15? 14. So the median becomes, really what you do is you add those two and you divide by 2, so you get 14 is the median. Okay, so why we can put the data into the calculator and it can tell us the median. Why I'm showing you this is because this can be, when you have a small set of data, it is much quicker to manually do it. In your head, you'll be able to do this quicker than typing it in the calculator. And time becomes an issue. We want time. Okay, so the way we often say we can, the way we can find the position, it's not the actual median, it's the position of the median. You can use this formula where you go N, which is the number of data, plus 1 divided by 2. So this is the position. So if you look, here's 1, 2, 3, 4, 5 data. If I did that here and I went to find the median, well, the median would be found at 5 plus 1 divided by 2, which equals the third. And is that did we find it at the third? Yeah, we did. So with this one, we had N equaled 6. So if I was going to go find the median, I would do 6 plus 1 divided by 2. So we end up with, it's in the 3.5. So that means it's between the third and the fourth, and you can see that. So why do we do that? Because maybe what happens if you get a set of, you've got this data and they said, because sometimes they'll display the data and you'll see all these numbers and they'll say find the median and you've got N equals, say, 53, yeah? So you can quickly go, all right, 53 plus 1 divided by 2. So it's at the 27th one. So you could quickly count up a frequency or something and you can work out where you are. I'll help you do them, but that's to show you what it is, don't worry. Okay, but obviously, as I said, we can find all these information that we'll need in the calculator. All of them except for, so we're going to find the mean and the median in the calculator. The only one we won't see is the mode in the calculator. And yesterday we saw that's the most frequent. You just have a look at the data and see which one comes up the most and you'll see that's the mode. All right, so I'm going to show you on the calculator how to find the mean and median, and we're going to use this set of numbers. So I'm just going to pause. Okay, so now we are going to do look at ways of displaying our numerical data. So a histogram is a good way of displaying continuous numerical data. So what are a couple of examples of continuous numerical data? Thinking back to yesterday, what's numerical but continuous? Continuous meaning you measure. What was a common one? Height? Yeah? What would another one be? Weight?
Age.
Yeah, age is a bit iffy. Age is because it depends how they measured it. Okay, so a histogram, you're going to see along here, you're going to see the numerical data. So say you had height. Now, when you have that, so when you often see, you'll see categories. So we might say from 140 centimeters up to 150, and then we'll go to 160 and so on. Okay, so really these become like our categories, don't they? It's like a numerical category. Anyway, and then we have along here is we might have the frequency. So say if we were in this, say maybe only 2 people had that, and then in this height we might say they came to 8. So this is what a histogram will end up looking something like this, yeah? So the big difference is it has no gaps. And obviously this is continuous numerical data. Remember the bar chart was for categorical data, so, and it had gaps. So this is for when we've got a numerical continuous, we're going to do a histogram. So in a minute, we're going to show you how to get the histograms up on the calculator. But once we've got this histogram, we obviously want to describe it. We want to say, what does it show us? This is what Further Maths is about. So the first thing we will do is you comment on the shape and whether it has outliers. So if you look here, if I have a histogram, and you'll see if the towers are really big at the start, so all up the start, and then it goes down like this, so then it gets small. So you can see you've got the big chunk up the top and then this tail at the end. That is positive skewed. When we describe the shape, it's called positive skewed. And now if you have the opposite, where we might start off a little bit small, and then it gets big at the end, so we've got the tail at the start and then it goes in, that's negative. Okay, so negative skewed. Sometimes if it looks like that, they're just, we would say without outliers. Without outliers, because what an outlier will look like, it stands alone, like this one here. Yeah, there's a little one by itself and it'll be separated. So if I drew this and then had this one out here, this one would be positive skew with outlier. Okay, so that would be us describing the shape. So you can either have positive, negative, or the last one is you can have symmetric. Symmetric is when it looks like it even, yeah? Looks like that. So it's got this bell shape, is symmetric. All right. So you just say symmetric without outliers. So that's the shape. So the next thing we have to talk about is the center. Now the center, remember I told you there was the measures of center? There was either the median or the mean. And the best way is probably to talk about the median. The center is where we want to know why we want to know the center, because that's where majority of the people or the data is, and so that becomes it's like the most common, so we want to know where that is. So your best bet is to quote the median, and I'm gonna just tell you why. We've talked about the shape, we've talked about the center. Now the last thing is the spread. So the spread is when you talk about the range, and you can either be the normal range, so the range is when you do the maximum minus the minimum, or we can use the interquartile range, which is Q3 minus Q1. So I'm just going to talk about the range now, because obviously the range, so when you're talking about the range, you just do the maximum value minus the minimum value, yeah? So it really, what it says is a spread. So say before, if you had the maximum of, we were talking about weight, say 100, and the lowest was 40. So the range ends up being 60. So everyone's weights are ranging within 60 kilos. So say for example, but what the IQR is the interquartile range is the difference between the Q3 mark and the Q1 mark. And why that would be better is, just say for example, you know how I said, all right, if we had all our data listed out, and once again, those extreme values would affect the range. So remember, if we had that, when we had the fatty boom bar up there, was a one-off at 200, and then the lowest down here at 40, but it makes my range huge, doesn't it? 160, and they're not ranging that much. So what we like to do is, if we take the say this is Q1 and this is Q3, this one's much better because it tells us the middle 50%. And so the middle 50% is a majority, and it's going to be more clear, because we'll probably say, all right, so we'll have say the 6, I'm making these up, so say 60 to 70, that's where they're roughly ranging. That's more like it, isn't it? That's more useful. That's where, if I was going to open up a jeans shop, I don't want a whole heap of 200 sizing ones. I want that, that's why it's more. So can you see that the interquartile range becomes a resistant statistic too? Resistant to those big ones. It's not affected by it, is it? So that's a better measure and much more, it's more appropriate. Okay, so when we're talking about the measure of center, we're going to talk about the measure of center. Probably the median is probably the best. And I'll tell you why. And particularly is best, and maybe you might write this, particularly for skewed data. So we're going to have a look at things. So say we had in here, and we're going to measure the kids, some people, we went into a class and we measured their weights. Okay, so obviously I've got a histogram here, and I'm going to measure their weights, and I end up with something like this. So if you like that, then it gets thing, and then all of a sudden I've got heaps up here. So say this is around, I'm going to say this is like the 80, 70, whatever, and then down here was our I'm going to say like our 48 kilos or whatever. So if I was finding out the median, where the median falls is going to be here, because we've got all our data up here, don't we? So the median's going to be up there. That's where everything is. If you were thinking about the mean, so remember the mean is when you add them all up and you divide by how many there is, yeah? So when you start adding them up, these little lightweights, they make it not add up to so much. So then your mean is actually going to be a bit lower, isn't it? It's actually down here. So it's not going to be a real true indication of how the class is weighed up. So it'll probably say in the end your average ends up being like low there, and we know that that's not true. There's not all these lightweights. So that's why the median's better. And then if you have it the other way, so say we went over up the street and over the road, we went into the St. Columba's class, and we've got all these weights up here, And then all of a sudden, and then we've got maybe, I'm going to throw a little outlier out here. So we've got our biggest loser contestant up here on the 200, and then we've got everyone else down here on our 50, whatever. Okay, so if you think about it, majority are down here on the median. This is where everyone is. But you can tell me those girls are not going to be happy if I say, well, let's get the class average. This person going to kill them, and she's going to drag that mean way up here. So they're going to say, well, your average weight, girls, is like 80 kilos, and then it's going to be hell to pay. So their better measure of centre is the median, isn't it? Yep. And so that's why we would use that. And what we say is the median is resistant to those extreme, isn't it? So it's a resistant statistic. It doesn't get affected by the big extreme values. When we come down to having symmetric data, so that's when we'll have the boxes where like we've got all the people in the middle and we've got like an even spread out like that. When you have the symmetric data, the median and the mean are very similar. They're the same. So it doesn't really matter which one, we can use both.